that. And today, friends, today onwards, Docker will be started. In this, those who want to exclusively learn Kubernetes, today Kubernetes will be started. So those who want to learn Kubernetes can join this today. Even they are freshers also. That means they have the knowledge of Docker, and if they want to learn Kubernetes, this is for them. Okay, and for them fee is 3,000 because they are only opting for Kubernetes, and for rest of the people in the same fee they will be continued. Okay, this is our Kubernetes first section. You got my point, right?
Yes, yes.
Yes. Okay, yeah, good morning all of you.
Good morning.
Today we will learn about Kubernetes, the most famous, and I can tell that this is the heart of whole DevOps, because this is where our application will be deployed into. And if I want to recap, Docker is a containerization tool. And with this, we will create the containers. The output here will be containers. Okay, containers. Then these containers we want to manage, we want to orchestrate. For that, we have a tool called Kubernetes. This is container orchestration tool. What is orchestration? In crude words, I can tell that orchestration means management. So in Kubernetes, what we do is we will automate the deployment, scaling, networking of containers which are created by the Docker. So that means somebody is asked, is Kubernetes is a substitute for Docker? No. Kubernetes uses Docker to create containers, and Kubernetes on top of that, what it does is it will orchestrate the containers that are created by the Docker. So in Kubernetes also, we have a distributed environment. Distributed environment means we will be having multiple Docker host machines. We will be having multiple Docker host machines. In these Docker host machines, container will be running, and those containers will be managed by the Kubernetes at the higher level. Okay, so now I want to just go through this theory. Kubernetes is an open source container orchestration platform. That means in order to install and use Kubernetes, we don't need to have any license. And one more thing is that the servers on which Kubernetes is running, definitely we have to pay for the servers, but the tool, Kubernetes tool, is free. Okay, so Kubernetes is an open source container orchestration platform that automates the deployment, management, scaling, and networking of containers. You will understand this practically going forward. Container orchestration is the process of automating the deployment, management, scaling, and networking of containers in a distributed environment. In a distributed environment means we will be having multiple nodes in the cluster. Even if one node is down, still your application will be available highly. Okay, how to achieve that? We will learn that in the Kubernetes. Okay, so Kubernetes was developed by Google using the Go programming language. And this amazing technology has been open source since 2014. This is some knowledge about the Kubernetes. And prerequisites to learn Kubernetes is definitely Docker. Good to have understanding of some Linux basics. Okay, otherwise also no problem. But knowledge of Docker is must. Okay, even you can learn Kubernetes without having the Docker, but how internally it is working, we have seen how volumes are working, what are the container, how we are creating the files in the container, how we are entering the container terminal. Okay, how we are networking, how we are pinging one container from the other. Those things we learned very clearly in the Docker. Okay, same things will be working internally in the Kubernetes as well. Okay, now let's see Kubernetes architecture. I said that Kubernetes is a distributed environment. It's a cluster of machines. Kubernetes is a cluster of machines. And the one which will manage the Kubernetes is called as master, or more specifically, it is called as control plane. Control plane. Then we have worker nodes. We have worker nodes or simply nodes. Okay, this no need to be this big. And they will be having network, and this we can call it as node 1. In Kubernetes terms, it is called as nodes. This is node 2. Let's see, node 2. So in order to orchestrate the containers, this control plane will be having some resources, some components, and the nodes will be having different components. The job of control plane is to control the activities of the containers. Now, if we go to the shipping world, we have control ships and cargo ships. Control ships and cargo ships. I don't know whether we will be getting that or not here. Okay, so this is a control ship. What this control ship does is some ships will be some cargo ships. Cargo ships means the ships which really does the job of transporting the containers from one part of the world to the other part over the seas and oceans. So the job of the control ship is to get to know how many containers were deployed on every cargo ship, and what are the movement of the cargo ship, what is the location where they are there, and all the activities of the cargo ships will be monitored by a single master ship, that is called as what? Control ship. Okay, so rescue operations, if something like if any technical technical failure is happened to the cargo ship, the control ship will take care of that. It will be having components and some computerized systems will be there for establishing a communication, that kind of thing. And same thing, and cargo ship is responsible for monitoring the ship activities. Okay, so now same like there, we have this, we can think of as a control ship, and these are the cargo ships. The actual containers will be, application containers will be running on the nodes, and control plane will take care of management activities. How many containers have to be deployed on each node, that kind of things will be there. If you go internally, what are the components that control plane will consist of? The control plane will consist of API server. This is called as what? Kube API server. Kube API server. Then scheduler. Then we have etcd. Then we have controller manager. Okay, these are the components. Node will consist of kubelet, then container runtime. In our case, it is Docker. Container runtime. In our case, it is Docker. Or let's write something like Docker. Then kube proxy. Every node will consist of the same components. Same component. You may be having hundreds of nodes, tens of nodes, but every node will consist of this. So for simplicity, we took only two nodes. Okay. So what are these components? What are their function? And one thing is, let's say this is a cluster. This is Kubernetes cluster. And we interact with the Kubernetes cluster. How we are interacting with the Docker? We are interacting with the Docker through Docker CLI. Docker run command we are using, Docker network. How we are interacting with the Docker engine? We are interacting with the Docker terminal, Docker command line interface. Then to interact with the Kubernetes cluster, we have a terminal called kubectl. Okay, this is CLI used to interact with the Kubernetes cluster. And we can also interact with the Kubernetes cluster through graphical user interface, GUI. Okay, but in 99.99% of the times we use kubectl only. This is in pipelines, we will be writing kubectl command. So these are two ways. Now let's understand the components. We have control plane and we have nodes. What is the job of Kube API server is, this is the entry point for our Kubernetes
Sir,
cluster.
the cubes. Hello.
Yeah.
Sir, can you please repeat this kubectl? Like, is it outside the control plane?
Yeah,
Like,
it is also
come.
outside the entire cluster. For example, let's say our cluster is running in AWS in the form of Elastic Kubernetes service. Then how to interact with that cluster? I should have some command line in my local. That command line is kubectl. For example, if you want to work with GitHub, you should have Git installed in our machine, right? Got it, Vinayak? Anyway, practically you will see this, then you will be having some clarity there. Now, what is the job of Kube API server is, it will validate the requests that are coming to the Kubernetes cluster. How the request will be coming to the Kubernetes cluster? Through kubectl command line. Okay, so now if I come and read the theory of this, Kube API server acts as the entrance to the Kubernetes control plane, and it is responsible for validating and processing requests delivered using client libraries like kubectl program. So that means using kubectl, using Kubernetes, what we do, we have to create the containers and we have to manage them. How many containers you want to create? What is the image that you want to use? Okay, let's say I want to deploy Nginx application, and Nginx application, if I want to deploy, I have to give specifications, right? For that, I want to use this Nginx image, and I want to use this port, and I want to name that container as like this. And this kind of things we have to provide. How we will provide? Through kubectl command. That request will go to control plane first, saying that I want to have 5 Nginx containers. This request will go to the control plane, and more specifically, this request will go to Kube API server. This request from this one will more specifically go to Kube API server. Kube API server will validate the request, whether the request is coming from the authorized person, whether the command is correct or not, whether that image is existing. All these things will be validated by the Kube API server. Now our request is to create 5 Nginx containers, same Nginx containers in 5 replicas. Now, what Kube API server does is, it will consult etcd. It will consult etcd, saying that Kube API server says to etcd that we got a request from the client saying we should have 5 Nginx replicas. Do we have that? That question will be asked by Kube API server to etcd. Why the question will be asked to etcd? etcd will consist of, will store the information about all the, about entire cluster. How many applications are running, how many containers are running, how many replicas for the same application are running, how many load balance are there, how many nodes are there. All this information will be stored in etcd database in key value pairs. Okay, so now let's come to this. This is a distributed key value store which acts as the single source of truth about your cluster. Okay, so whatever the cluster information will be there, that will be stored in etcd in the form of key value pairs. It holds configuration data and information about the state of your Kubernetes cluster. That is the job of etcd. Now, Kube API server asked etcd to provide information about this request. And etcd will say that, no, we don't have any Nginx application with 5 replicas. That information will be given to the Kube API server. Okay. Now, what information we got from the etcd? We don't have the Nginx application with 5 replicas. That information now will be coming to Kube API server. Now, what this Kube API server does is, it will consult scheduler. It will consult scheduler. Why it will consult scheduler? Now, Kube API server will say to scheduler that client is asking these many things, but we are not having in our cluster. Please schedule them. Scheduling means we wanted to have 5 replicas. Now the scheduler, what it does is, it will schedule the pods or the containers. We will understand the difference between pods and the containers. Now, what it says is, wait friends, so Venkat is not able to join the session. Sorry, Venkat is not able to join. Wait friends. Okay, I think when I have shared that, wait. Okay, now what scheduler will do? Kube API server asked scheduler to schedule 5 Nginx replicas. Scheduling means what? To decide where these 5 replicas should be running. It will tell that, scheduler will, what it does, out of these 5, okay, out of these 5, 2 containers should be created on node 1, okay, and 3 containers should be created on node 2. How scheduler will decide how many have to be created on this node and this node? Base, it has kube scheduler will be having algorithms in it. So in algorithms, it will check what it will be defined there. Based on the resource availability in the node 1 and node 2, these containers will be distributed across multiple nodes. Okay, and we have also manual scheduling that we will learn during the course. Now, scheduler, what it does is, it will just tell where this particular container should be running. That's it. Who have to create that scheduler? That is the job of another person. Okay, the scheduler now will tell that the containers should be running 2 on node 1 and 2 on node 3 on node 2. That information will be now coming to Kube API server. Now, Kube API server will send the entire information to kubelet. kubelet. Okay, I will come to this component later. Okay, kubelet and kubelet. Now, what the information in that will be? These two containers should be created. What is the definition of those container? The definition of the container is will be specified in this client command. So what the image should be nginx image. Okay, the container name is also, let's say, nginx itself. Okay, now kubelet now got that request, and now kubelet will act as the agent of the control plane on the node. What is agent? Agent means, for example, let's say we have central government and we have state governments. Who is the agent of center government in the state? Can anybody unmute and tell me?
Governor.
Yeah, very good. Governor is the agent of the center on the node. The administrative affairs of the state will be reported to the center through governor. So like that, kubelet here is the agent of control plane on the node. Okay, so first the request will be coming to the kubelet. What request it got? In this node, two containers should be created using nginx image. Okay, then who will create the containers? Obviously Docker. So kubelet now consult Docker and will tell that please create two containers. Okay, that two containers will be created. And after that, these two containers will be wrapped wrapped inside a box called pod. So container will be created by the Docker. Later, kubelet, what it does is it will wrap the containers inside a box called pod. Okay, so like this, another container will also be created and it will be wrapped inside a box called pod. Okay, now this is for now they are independently running. Now what is the kubeproxy job? The job of the kubeproxy is to assign IP address to the pods, okay, and network them. That is the job of the kubeproxy. So now this is happened on node 1. Coming to node 2, same thing will be happened. The kubelet has got information saying that it should create three containers. Okay, three containers will be created by the Docker. They will be wrapped inside the boxes called pods. Okay, so just pod is nothing but an abstract layer over the container. Okay, that is, and kubeproxy is responsible for networking. Now, what is the Java controller manager? We wanted to have 5 replicas. Yeah, Vinay.
The for two containers, two separate pods will get created, or only in one pod two containers will get created?
No, for every container, one pod will be created. It's not that one pod will be created. Every container will be put inside a pod. And we can have multiple containers inside a single pod, that we will see going forward. Okay, we can have multi-container pods as well, but for time being, let's restrict the discussion to the single container pod. Okay, so this is done. Now, what is the job of the controller manager? Now, our request is to have 5 replicas for the nginx application. But what if one container or two containers are deleted due to some reasons? If 2 are deleted, out of 5, only 3 will be there. But what is high availability? We should have always 5 pods up and running, 5 instances up and running, but 2 are deleted, only 3 are running. But our desired state is to have 5 replicas. So who will take care of that? For that, controller manager will take care of this preserving the desired state. If 2 containers, if 2 are deleted, that information will be given to KubeAPI server and it will ask the KubeAPI server to create 2 more containers, so that total it will be 5 containers. That will be the job of the controller manager. And in Kubernetes, if one node is down, our desired nodes is 2. If one node is down, it has to, we should have 2 nodes always. If one is down, one more should be created. That will be taken care by the controller manager. Now, the controllers in the Kubernetes are responsible for controlling the state of the cluster. Okay, so state of the cluster in the sense the state of the number of nodes and number of pods. Okay, you will understand. We will simulate the node failure and pod failures. There they will be created, and we have done that. And if we use cloud-based Kubernetes, then we have another component called cloud controller manager will also be there. Okay, so this is something like API to interact with the EKS and GKE and AKS cluster. Okay, that is. Now, how to install this Kubernetes? There are different platforms. AWS has come up with the managed service called Elastic Kubernetes Service.
If you could add this diagram in our notes, it will be great, sir.
Okay, sure. I will do that. Azure came up with the managed service called Azure Kubernetes Service. GCP is having Google Kubernetes engine. Okay, these are the managed service. So once we create EKS cluster, that means control plane will be provided to us by the AWS itself. And one thing is that obviously we have to pay for the service that we are using, and it will take care of the control plane availability. Okay, that means if the control plane is down, then it is the job of the AWS to make sure that control plane is always up and running for us. So underlying servers will be managed by the AWS itself regarding a control plane. Okay, so we don't have any visibility into that server. Okay, so for your sake, what I will do, if I do this, I think the entire document will be disturbed. I will keep somewhere at the end or somewhere.
Screenshot also. Screenshot will also work.
So going forward, you don't need to. You will understand how these things are working. So Kubernetes will also be called as K8s. Why it is called K8s means between K and S, between K and S, 8 letters will be there. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, between K and S, 8 letters will be there. So generally, this is also called as K8s, Kubernetes. Okay, this is what Kubernetes. And if you want to practice, we have a single node Kubernetes called Minikube. Minikube. Okay, this Minikube will be having a single node, and that node will be acting as control plane as well as the node. Okay, and we have KubeADM to install Kubernetes in our on-prem machines, in our own machines. But in most of the cases, people will be using managed service EKS and AKS because control plane will be taken care by that, and we can use AWS EC2 instances or Azure virtual machines for nodes. Okay, that is. So we have a Minikube.
Sir, in
So on
real time, we
Ubuntu,
are using Minikube or
In real time, we will be using EKS cluster.
okay, sir. Are you going to tell in Minikube or AKS question, sir?
I will tell only in EKS.
like is some
Okay.
okay. If
And whether
someone
it
is
can be,
using Ubuntu on their base OS, then if he can use
yes,
Minikube, right? No,
yes.
the feature will be
Whether,
same, command will be the same.
yeah, whether it can be EKS, AKS, or AKS, any KS, all the commands and all the things will be same except where it is installed. For example, Docker can be installed in Windows and it can be installed in Linux. Will the commands will change? No, same commands will be there. Git can be installed in Windows and Git can be installed in Ubuntu. Will commands will change? No, everything will be same. Like that, whether it can be in Minikube, EKS or AKS, that's fine. But I will use EKS because in real time, mostly if you are using AWS, we will be using EKS. So that's why I always use EKS. And so this is being deleted. Now one thing is, I will tell you how to install, and you can go through the documentation and you can see how to install Minikube. Otherwise, I will show you that. See, we have cluster. Inside cluster, we will be having nodes. Inside the nodes, pod will be there. Inside the pod, container will be created. This is how the hierarchy will be. Cluster will be having nodes. Inside the nodes, pod will be there. Inside the pod, container will be created. 1 minute, friends. Okay, so this is.
Yes, sir. I have the doubt. Like this cluster will get created on separate virtual machines, or nodes will get created on the separate virtual machines.
Cluster is what? Group of nodes is called as a cluster. And in cluster,
Right.
we have master and the nodes. Okay, can you
In
please
one
repeat
cluster,
your
correct?
question?
I'm asking, like in this case, like master and nodes are there. The master will be on the separate virtual VM, and this node on the
Yes,
separate VMs, right? Now,
yes,
and
yes.
this entire things we call as cluster.
Cluster. If you take Minikube, control plane, in Minikube only single node will be there, and that node will be acting as both control plane and the nodes. That
Okay,
means container will be created on that node. So if you take this control plane, see, do we have the container runtime here in this node? No, if you don't have the container runtime, that is Docker, pods won't be scheduled on this, pods will be running on all this, but we can make, we can have the container runtime here as well. But if you take managed service, that facility is not there. But if you install your work Kubernetes cluster, use KubeADM, then you can use this control plane as a worker as well. So that means control plane will act as both master and the node.
no.
Okay. So how to install this kubectl in Windows? I will tell you. For that, what you have to do is you just have to go to this page, or directly you can execute this command. Okay. If you are using Ubuntu, there also you can install kubectl. See, this kubectl is being installed, downloaded. Once it is downloaded, what you have to do that you have to set the environment variable for that. Otherwise, if you don't want to take that risk, you just have to copy this into system32 folder. Go to C, go to Windows. In Windows, system32 folder will be there. In that, what you have to do is just copy that kubectl
Is it like
executable.
CMD? Is it like CMD tool or Git bash tools
Yes, yes,
like that?
yeah. It's a CLI. Okay, you just have to copy that into the system32 folder in Windows. With that, after doing that, if you go to CMD, okay, if you type for kubectl, see, you will be getting this kubectl version also you can type.
Cube proxy is also available, sir.
What?
Cube proxy.
Kubeproxy, yeah, Kubeproxy is a component that is there in the nodes. That is for networking. Okay, so kubectl is installed. What you have to do? You have to execute this command. You have to download this file and copy that to system32. With that, kubectl will be installed. And if you have the Visual Studio Code, if you open our Visual Studio Code, and if you open a terminal in that, so that you will be also able to execute the kubectl command, because tomorrow you will ask that how to integrate kubectl with the Visual Studio Code. You don't need to do any configuration. Okay, once that is installed in our system, means that will be also available in the this VS Code. So kubectl hyphen version. Okay, I think this is not available. This flag is not there. Okay, it will show that is kubectl. Even if you press this, you will understand. Okay, that is. Then after that, how to install Minikube? If you don't have any AWS account, or if you don't have any Azure account, I recommend you to create one and create your Kubernetes cluster. But if you want to practice in our own machine, then you can go for Minikube, but I don't recommend this. How to install Minikube? You just have to copy the URL, or directly you can execute this with this Minikube will be downloaded. Once Minikube is downloaded, so you have some requirements for Minikube to be installed. You should have at least 2 CPUs and 2 GB of free memory and 20 GB of free disk, and obviously should have internet connection. Then only you will be able to install Minikube. Okay, so how to install that? Once we do that, if you perform all these activities, add the Minikube bandit to your path. Okay, we have to add that to our path. Then what I will do is I will copy that to system32 itself. I did not use Minikube till date. I have used that in Ubuntu machine. So now let me go to the CMD. Minikube is not recognized. What we have to do is we have to run this. To execute these commands using PowerShell, to open, to run this as an administrator. Copy that. What it is saying, the request Java could not create a circuit channel at line. So we have to set this environment available and all. I think we have to run this first, friends. Okay, it will take some time to run this. It is opening. Will be opened. It may take some time. Okay. With this, what will happen? Minikube will be started. Minikube will be started, and I should also be able to run this in the terminal or here itself. Minikube status. I think that is not CMD. Okay, so this we can do, but why I'm not able to do that here? I have to rerun the terminal. Minikube status. Why that is not being recognized here? What?
Environment is not set.
Yeah, that is said. See, now Minikube start. Now let's try to run kubectl get nodes. Context, what it is saying. Oh, yes, yes. I have to install Docker first, friends. I forgot to tell you that. Docker is not there. Okay. So we have to install the Docker. How to install Docker in Windows, we have seen. I think I have not taught that, but we have that in our documentation. Just Docker desktop we have to install. Install Docker in Windows. So the error that we are getting is Docker is not installed. Okay, when we install Docker in Windows, we also have to install Windows subsystem for Linux. Okay, so this thing also we have to install along with the Docker. Why do we need to install this? If you go to first class, you will understand. Docker first or second class, you will understand. Okay, because containers will be using underlying kernel, but we don't have Linux based, Windows based containers. We work with only Linux based containers. So for Linux based container, we should have Linux kernel that we start using Windows subsystem for Linux in Windows. That is okay. So this is how to install Minikube. Minikube has been successfully installed. To interact with the Minikube cluster, we use kubectl, but Docker has to be installed first. Okay, but I will do the things in only EKS cluster. How to create EKS cluster, we will see in the next class. That is tomorrow. That's it for today,
Okay.
friends. If you have any doubts, so you can ask me. And as a part of Kubernetes, we have about 94 pages of these notes and some other pages, some wherever necessary, we will also go to Kubernetes official documentation for getting the API groups and all those things. I will take to that. Notes will also be given to you. The exact notes will be given to you. That is
Okay. Okay.
okay, friends. Thank you.
No
Sir,
problem.
Yes.
sir, how to connect with power that I mean that file. What is that one? So
kubectl.
VI Studio that blue.
Yeah,
Yes, how to connect this?
kubectl is already there right here. kubectl is installed. You want me to tell kubectl state this one, right? Once kubectl is installed, you will be able to interact with the Minikube cluster, okay, with kubectl. But I don't know why we are not able to start this here. This may be due to we have to
Docker.
run as the administrator. Yeah, Docker we have to install. But before that, I'm able
Can
to.
you restart VS Code, sir? I think so. That is the issue.
Okay, let's do that. But once we are able to start Minikube anywhere using PowerShell or anywhere, then config file will be created. With that, kubectl commands can be happily executed here as well. But this Minikube starting, oh right, now it's working. As you said, that is working. We have to restart the VS Code. Okay, so unable to pick the Docker not installed here. Okay, so Docker has to be installed. That's it for today, friends. If you have any doubts, you can ask me.
Sir, is it workable only in PowerShell for writing?
Balasubramanian, I'm not getting you. Could you please a
Sir,
little bit louder?
yeah. So why PowerShell is taking here and also command prompt also? What is
PowerShell is used to execute PowerShell scripts.
okay, sir. It is YAML script only, sir.
No. Not YAML script. PowerShell script is different.
So,
And we will be using Elastic Kubernetes service. So no worry.
Yeah, Elastic Kubernetes service we will be using. We will be
so
connecting to that.
this Visual Studio and Kubernetes, how to connect? I could not get it exactly.
That's what I said. I think you only have asked, not you in other class, how to, no need to do any configuration here. Once we have the Visual Studio code, we can directly run the kubectl commands there as well. Okay.
It
This
is already
terminal,
pre-installed, sir.
yes, your terminal pre-install means the, whatever the terminal command line is there in our machine, that terminal will be opened here.
And Visual Studio you need to install in your machine
Yes.
separate.
Is there any setup to work out on this, sir?
No. Once you install Visual Studio Code, and if you open the Visual Studio Code, and you just have to open the terminal here. That's it. That terminal is nothing but this command line only. Okay. This is this terminal only. This thing.
Okay.
Okay?
PowerShell is different.
PowerShell is different.
Uh,
You can execute some additional commands using PowerShell. Yeah,
sir, I have one doubt. Can I share my screen, please?
you can. For
Okay.
that, I have to do something, right?
Hi, permission, right?
Yeah, make co-host. I made you as a co-host.
Yeah, 1 second, sir.
Class is over. Remaining people can leave if they want. Otherwise, you can stay here.
Right. Okay.
Sir, my screen is visible.
Mhm.
Sir,
Yes.
actually, yeah, I was preparing a Docker Compose file. So so this you already thought, but my question is, we have MySQL username and password, right, sir?
Mhm.
And in the Spring Boot application property, so if we create here username password, this only username password we have to give, right?
Yes.
So that is compulsory. So database name, username, and password. This
We are
we what do
passing the environment variables to the database. Okay.
okay.
Oh, yeah.
So in the property file also same thing I have to mention, right?
Yeah.
Okay. Yeah, got it, sir. Yeah.
Okay.
And but is this yeah, this is also inside the like is
Inside
this
the
safe like directly passing here or like
yes.
okay.
In Kubernetes, what we do is we have the secrets concept there.
Okay, got it.
Okay.
Yep.
Sorry, is it mandatory to buy domain, sir, for Kubernetes?
No need. Why you got that? Oh, where do you want to use that domain?
So someone said that for personal things, I don't know exactly what it is, but it is ready. Is it necessary
For
to buy?
example, we will be having the load balancer, right, in Kubernetes. For that load balancer, if you want to just get real feel of accessing that your own domain name, in a name or CNAME record, what you do in a name, you will give the load balancer URL and you will attach that to your own DNS name. So with that, you can access that load balancer through your own DNS name. Apart from that, there is no need of having that for Kubernetes, these classes. Arnav is asking, what is that ISTO? I don't teach this. No. I don't teach that.
Staging.
No, I don't teach that. Okay,
Sir,
friend.
I have one domain, a free domain. Sir, can you just implement that in future, sir, if possible?
Yeah, that will be good if we can, like,
Yes,
for the application you are saying.
Yes, sir.
you have the
Okay.
domain. What do you want to do with that?
Sir, I want to host one website on that web application.
Okay.
Web application. Okay.
So domain name, if you have, what you can do with that, you can use that domain name with your load balancer URLs or IP address. Yeah. But if that domain where you have bought, if they are also providing the hosting services, you can put your files there and you can host directly from there itself.
Oh, yes, sir.
Okay. Thank you, friends. Bye.
Thank you, sir. Thank you, sir. Good day, sir.
Okay.
Thank you, sir. Bye.
Bye.
Bye.